Hello, everyone. A very warm good evening to all of you, and welcome to Unacademy. Welcome to the session of NCERT Basics and the NCERT Fundamentals, where we are covering one by one the entirety of the NCERTs. In the past couple of weeks, we have managed to cover the entirety of the portion of geomorphology, and now we have also gained enough amount of conceptual clarity and information when it comes to the case of climatology. Now, today, we are going to take a look into the aspects of the details of climatology, for example, the types of clouds. What are the various different types of cloud formation which is being experienced? The different types of rainfall. For example, in a country like India, majority of rainfall received is of a certain kind. What is that? Then also we will take a look at the fact that where across the world, which are the major areas across the world which end up receiving rainfall. We are going to link it with the tricellular model of atmospheric circulation that we had already studied. This will help you understand the world climate as well. Okay. Tomorrow, we are going to initiate the case of oceanography, the link for one chapter, that is the world climate, Köppen's classification. I will provide you with the link for that video, right? Do watch that video. And it is a very detailed coverage of global and the world climate also. PYQ discussion has also happened in that video. So that will cover your entirety of climatology. A couple of more classes are left, whereby we shall be covering the portion of oceanography. And overall, I do hope that in this particular series, you have gained tremendous amount of conceptual depth. Your mails and your frequent messages, they continue to provide us the necessary boost. However, if you do like the initiative, don't forget to bless us with your click on the like button. Do share it with your friends. Let them know what conceptual clarity in geography is about. And if you have not subscribed to the channel, do subscribe to the channel, and we will continue these series furthermore for the other subjects as well. Now, having said that, an announcement for all of you. Yes, the series will cover the portion of Indian geography as well, but that will be done next month. Okay. So there will be a gap in which you can revise the portion of physical geography. I don't want you guys simply to be reading around. I want you guys to understand it, revise it once, and then the Indian geography again comes around next month, and that will ensure your entire coverage of geography is completed. Today, map classes did happen. Yes, map classes 5 to 6 p.m., Monday, Wednesday, and Friday. That is going to be consistent. Okay. Now, before we proceed ahead, an important announcement for all of you. Now, as the candidate, we are oftentimes confused which course to follow, which educator to follow, which optional to take, where the good test series are, and so on and so forth. Now, for that, oftentimes the various institutes want you to enroll directly into the batches. Now, we have come up with the offer of a free trial. All that you need to do is register with the phone number which you have not already used on this platform. Register with the phone number, download the test series, access the test series, look at the lectures, and thereby get an understanding about what quality information or what quality courses are. If you are, let's suppose, not interested or not impressed thereafter, you feel that there is no much value addition, there is nothing lost for you. But if at all you feel that even if there is a 5% incremental addition to your content, 5% addition to your conceptual clarity, do enroll for that course and ensure that civil services preparation is an informed journey and is not something that you do just out of sheer inertia or because your friends are participating in that. So, this is the moment for you. Many of you are confused between sociology, anthropology, geography, history, which optional to take. Use this opportunity, register with a mobile number, and take a look at the lecture, the coverage, and how detailed the coverage is. If it impresses you, go ahead with that. Or you can carry on with the remaining preparation. Now, coming to the chapter, we are going to cover, and we were covering the case of water in the atmosphere. Here, we had covered the case of humidity, right? Humidity is what we had covered. Now, in the case of humidity, we had covered the cases such as your portions of absolute humidity, specific humidity, what is relative humidity. And one very important concept that we had touched about is the case of the carrying capacity of air. I hope we recall that. Carrying capacity of the air. Okay. Whereby we had discussed that any air parcel anywhere in the world, that air parcel will have its own ability to carry the amount of water vapor. Beyond that, it cannot carry any more amount of water vapor. And that is where I provided the analogy of a candidate's brain, right? For example, a candidate like you, let's suppose they are studying history, geography, polity, economy in the same day. I'm sure the remaining two subjects will simply be an addendum. It will not go inside your head because your mind has reached saturation. Just like that, air also has got a limit, that is your carrying capacity. And this carrying capacity is related to what? This is related to the case of your temperature. Higher the temperature, greater is the carrying capacity of the air. Now, do we rectify this? Do we learn or memorize this information? No. Okay. If you have been following the NCERT classes, by now, I'm sure you would know that I'm strictly against the rectification and memorization techniques. It is conceptual. The entire subject is very conceptual. So, how do we understand the concept of carrying capacity in brief? Basically, just draw a parcel of air. In that, draw the air particles, the gaseous particles. Now, if the temperature is high enough, the particles will be having a very high level of energy. They will escape the system. That means in the air parcel, there will be more space for water vapor to be accommodated. So it will be able to hold more water vapor. So that is why higher the temperature, greater is the carrying capacity. Okay. Greater is the ability to carry the moisture along. Now, with the help of that, we also understood the case that relative humidity is inversely proportional to temperature. If the temperature increases, relative humidity reduces. And that is something we have also seen in the video for the wildfires in Europe. Now, what happens if the air is cooled down beyond the point of saturation? Then what will happen? Its carrying capacity reduces. It already has got enough amount of moisture, and now the carrying capacity has further dropped or dipped. In that case, you will always have the case of condensation, isn't it? You will always have the case of condensation. Now, when we talk about the case of condensation, now condensation occurs in various different types, in various different places. For example, if I consider the ground surface, let's suppose condensation occurs in the surface associated with the ground, in the air which is touching the ground, right? Then what will happen? You will have the formation of dew, isn't it? Now, when will dew formation take place? Dew formation takes place once the air is cooled down to such a temperature that it hits saturation. Any further cooling leads to droplets getting created on the grasses, on the metal pieces, on the vehicles, etc. Right? So, that temperature at which the air hits saturation and thereby the dew formation is initiated, that is known as dew point, dew point temperature. Now, tell me one thing. What if in a place air is dry? So the dew point temperature will be high or will it be very low? These kind of questions will be asked in the exam. Okay. If the air is dry, in that particular case, dew point temperature will be high or will it be low? Apply your logic here. It will be very low. Why? Because a dry air means that for it to reach saturation, dry air means what? Humidity levels are very low. Vapor present is very low. So, for that air to reach saturation, its carrying capacity has to reduce quite tremendously. Okay. So, for example, if you have a dry air parcel, that means vapor present is 2 grams. Carrying capacity is 10 grams. So, for it to reach saturation, it has to cool down to such an extent that the carrying capacity becomes 2 grams. So, it has to cool down quite substantially, isn't it? So, that is why drier air dew formation happens at very low temperature. That is why in the regions like Delhi, Lucknow, Amritsar, Chandigarh, in these areas, dew formation will be observed only during winter nights. Whereas in regions like Vishakhapatnam, Mumbai, Goa, Thiruvananthapuram, Chennai, Kolkata, in these areas, humidity level is very high, moisture level is very high. So even if the carrying capacity reduces slightly, dew formation can happen. That is why in coastal areas of the country, you will observe that dew formation is something which can be experienced almost throughout the year, mostly during the rainy season in the evenings. Slightest reduction in carrying capacity due to fall of temperature, dew formation. Okay. Now, furthermore, what if this dew point temperature in a certain place is less than 0 degrees Celsius? If in that particular case, what will happen? In that case, rather than liquid water droplets getting created, you will have ice formation on the ground, thin layer of ice, and that is known as frost. That is what you will observe as frost formation. Early mornings in Pathankot, early mornings in Shimla, early mornings in Srinagar, Leh. Leh, not so much because the air is very dry in the case of Leh, but Gangtok, right? In these areas, during winter mornings, you will observe thin layer of ice associated with the poles, the electric poles, the telephone poles, the metallic sheets, etc. That is the case of frost formation. Okay. Then, for example, what if the air in contact with the ground surface, this air cools down and there condensation happens? Netarhat as well in Jharkhand, correct. If the air cools down and here condensation happens, then what? In this case, you have the formation of fog, or in certain cases, even mist. What if in a certain area, air rises up and the condensation does occur at upper atmosphere, at higher altitude? In that particular case, you will have the formation of clouds, right? That is how you have the case of cloud formation. Okay. So all these are parts of condensation or the aspect which is created because of condensation. And in all of them, what is the common factor? Common factor is simple. Air cools down, reaches saturation, cools further, condensation. Okay. That is the case of the formation. Now, let's have a very quick recap about the formation of a cloud, something that we covered in the last session as well. But let's have a quick recap in order to understand why rainfall occurs. So, in any particular area, let's suppose there is heating of the ground surface, or, anyways, if there is a rise of air. Now, simultaneously, while you are drawing this diagram on your page, I hope you are drawing those diagrams as well. On the sides, note this flowchart also. It will help you in revision. Rise of air, let's suppose it occurs. Rise of air will always lead to Lower temperature, cooling of air, right? Cooling of air basically means carrying capacity reduces. Now, the air as it rises further, it will cool down further. Carrying capacity will further reduce. As a consequence of that, what will happen? It will reach saturation, reaches saturation. As it reaches saturation, thereafter, if it further rises up, condensation. And this condensation will occur where? For any condensation to happen, you basically need particles, surface. Without a surface, condensation can never occur. Condensation will never occur out there in the thin air. So that is where you have these dust particles, very good, which serve as hygroscopic nuclei. And these dust particles, they serve as the surface around which the condensation does occur. Now, in majority of the cases, by the time that air hits this condition of condensation, the temperature reduces to such an extent that you will find the formation of tiny ice particles. Now, here comes an important concept. Kindly pay attention. If you consider the ice particle, earlier dust particles, they served as a surface for condensation. Now, this ice particle, that will also serve as a surface for condensation, isn't it? Imagine there is an ice particle, vapor is rising up. As that vapor will get in touch with the ice particle, its temperature will drop suddenly, it will condense. So, like that, you will have either supercooled liquid or you will have larger ice particles getting created. And a combination of all of these, the ice particles grow larger and larger in size. Eventually, a combination of all of these is what leads to the formation of a cloud. So, clouds, they are not your absolute solids like you would have seen or you would have imagined from your childhood days in cartoon movies that a cloud is there, an airplane hits it, and the cloud moves away. No, you can actually move through the cloud. You can, in skydiving, you can fall through the cloud, right? It is made up of very tiny particles of ice as well as water droplets. Now, in this cloud, you will observe that some of the particles are very, very large because of continued condensation which has happened around the ice particle. So, understand the entire logic of it. First, you had the case of the dust particle. I hope you can see the dot on the top left corner of your screen. Now, around that ice particle, initial set of condensation happened where you had the ice formation, right? A small ice crystal is getting created. Now, in the meanwhile, more water vapor and more air is rising up. Now, this water vapor is getting in touch with a larger surface as compared to above. So, as it is getting in touch with that, what happens? Its temperature suddenly drops. As its temperature drops, it will also form ice. Size increases. Now, again, another parcel of air is rising here. It will get in touch with the ice particle, which is now larger. So the surface area is increasing. That means there is more surface for ice particles to accumulate. Slowly and steadily, the size increases. Right? So, like that, you have these large sized ice particles which get created. Now, eventually, they become so very heavy that these ice particles, they cannot be upheld by the wind and the gravity anymore. And by the wind rather anymore, and the gravity pulls them down. Okay, they become so heavy that the gravity eventually pulls them down, and that is when, as they start falling down, what do they experience? They experience air resistance, right? Air friction. So you have that ice chunk falling from 4 kilometers, 5 kilometers, even 10 kilometers up in the sky. They will experience that air resistance, air friction, that is heat. And because of that, you have the case of the ice melting. And that ice, as it melts, it gets converted into what? Liquid water droplets. And these liquid water droplets will cause rainfall. So initially, you have the ice which starts to fall. That ice experiences air friction and air resistance, due to which that ice melts. And as a consequence of that, eventually, rainfall is created. Yes, the mapping classes are free Monday to Wednesday, and Friday, 5 p.m. Now, this is why rainfall occurs. But in certain areas, you experience snowfall. For example, in regions, when we talk about regions like uh, initially the nucleus is not heavy, no. Now, in certain areas, you experience snowfall. For example, when you go to Srinagar, when you go to Sikkim, when you go to parts of Arunachal, Uttarakhand, Himachal, you experience snowfall. Why do we experience snowfall? Is it the case that something very different happens? The answer is no. So, understand the case of the snowfall as well. So let's suppose you consider a region which is very cold. So here, initially you have the cloud, and the cloud will have these ice particles. Now these ice particles, they will start to fall. Okay. As they start to fall, now they will experience the air friction. As a result of that air friction, these particles will melt, isn't it? They will melt. They will melt into liquid water droplets. But in these areas that we have talked about, the ground temperature is very low, 0 degrees Celsius, -1, -2 degrees Celsius, and even lower. So here, the ground is very cold, very cold. So air in contact will also be cold, also cold. As the air in contact is also cold, so that is where, excuse me, these water droplets, they will start to refreeze. And they will refreeze into tiny ice crystals, which will fall in the form of snowfall. That is how you experience snowfall. So, in the case of snowfall, what are the processes? You have initial melting and eventual refreezing. Okay. Both of them are associated with the case of the snowfall. That is how you experience snowfall. Okay. Now, what is the concept of artificial rain, by the way? That is also something which you study in current affairs quite often. What is this concept that artificial rainfall is being created? You see, in areas, for example, like Delhi, right? In areas such as UAE, Gulf nations. Now, the story initially starts from the 1940s, by the way. In 1940s, few of the engineers in Bell Electronics, they wanted to create this rainfall, They wanted to mimic the natural condition and create rainfall in US. So what they did was basically they used certain particles like silver iodide, and they sprayed silver iodide, and they found that at low temperature that can also act as a surface for condensation. So that is where the US Defense Forces then acquired that technology. Eventually, they started what is referred to as Project Cirrus, under which they thought that they could, by using this artificial cloud, they could control the tornadoes from occurring. Obviously, it was a failure. Then the Soviet scientists also started researching into them. They carried multiple bouts of rainfall in Moscow by this artificial rain after multiple attempts, obviously. Then you had the case of the large scale implementation being tried since the 1990s in the Gulf nations. Now, the global usage and implementation on a large scale was experienced in 2008. 2008 was the year when China wanted to announce its arrival to the world. China was hosting the Beijing Olympics. Now China had spent huge amount of money creating the infrastructure because it wanted to create a positive image of China across the world. Mind you, 2004 to 8, Chinese economy was of the same size that we are today, around 4 to 5 trillion dollars. It wanted to project its power across the world. So while it created these large stadia and these large accommodation and huge infrastructure, but the athletes were complaining. The air was so polluted in Beijing that nobody could move without mask. And that is where, rather than gaining good name, China was being defamed. Now, what did China do? There were doubts that even the massive grand opening ceremony for the Beijing Olympics that could be cancelled because the air in Beijing was so polluted. So China created this artificial rain, and that took away the pollutants. That is when the rest of the developing world woke up to this idea that we can also do so. That is why during winter months, even in India last year, you had one of the failed experiments to create artificial rain over Delhi. So, what is the concept of this artificial rain? You basically either fire a rocket from the ground, small rockets, and that rocket detonates up into the sky, spraying particles like silver iodide, etc. Right? Now, these particles, they are at lower temperature up in the atmosphere. They create an accelerated rate of condensation. In the same place, accelerated rate of condensation will occur. So that means larger ice particles and larger water droplets will be created. And that will eventually create that rainfall. It can be done by aircraft as well. But then in Delhi, that was a failed experiment. Why? Everybody criticized the government that the government could not even create artificial rain. The government is good for nothing. But please understand this. Even for that artificial rainfall to occur, you need moisture in the air. You need sufficient moisture which can eventually carry out condensation, form those droplets. In Delhi, when do we do that? In the month of October and November. That is way past the rainy season and Delhi is dry. Maybe in October and November, if you carry the same experiment in a Mumbai or a Chennai, it will work. But in Delhi, it will work when you have moisture. Because Delhi is so dry, that is the reason why the experiment eventually failed. It cannot create moisture on its own. It can allow the moisture to condense at the same place so that chances of rainfall increases. So that is the entire concept around artificial rain, which now you know in detail. Now, when we talk about the case of the clouds, okay? Now, clouds are of various different types at various different levels. Now, in the book, you will find these. I will give you the list also. various different types: cirrocumulus, cirrostratus, cirrus, altocumulus, altostratus, nimbostratus, stratocumulus, stratus, and so on. Does it have any effect of use? No, because it is such high in the atmosphere, it dissipates on its own. Now, here, how do we retain and remember all these clouds? So you have the various different cloud types. You have cirrus, cirrocumulus, okay? You have cirrostratus, then you have altocumulus, then you have altostratus, then you have stratus, cumulus, stratocumulus, okay? Then you have the case of nimbostratus and cumulonimbus. These are the types of clouds. You can have questions asked from this. Now, how do I retain all of this? Is it because God has gifted me with extraordinary memory? No. There is a simple strategy to retain all of this. First of all, you have to understand that clouds can be created at various different heights. You have the low level clouds, mid level clouds, and high level clouds. Accordingly, the name cirro or alto is attached. You also have multi level clouds. Okay. Then the clouds, when they get created, so you have various different types. One is the case of very high level clouds. High level clouds. These are known as cirrus. Okay. Then you have the case of, if you talk about the classification of cloud, you have certain cloud types which develop horizontally rather than vertically. They will develop horizontally. They will develop a layer. This is known as stratus. Stratus derived from the term strata, which means layer. So, whenever you have horizontal expansion, that is your stratus kind of clouds. Then you have certain clouds which develop vertically, like balls, heaps of balls of cotton. You have vertical development of such clouds. This is an accumulation in one place, not the development horizontally, but accumulation in one place. This is known as cumulus. And then you have rain bearing clouds or multi layered clouds. Multi layered rain bearing. Rain bearing, as in, they will definitely cause rainfall. That is where the term nimbo is attached. Okay. Based on this basic principle, you have the entire naming of the cloud which is done. Then you have the case of prefix of the cloud that is associated with height, plus suffix of the cloud which is associated with the type. So, high level cirrus, mid level, you have the prefix that is alto, which is used. Low level, no prefix. Okay. These are the basic norms of the naming of the clouds. Now take a look at all these clouds. So, high level cloud, either it will be, when you talk about, let's suppose a high level cloud, it will be either spread out just like this, form a horizontal layer. I hope you are able to see forming a kind of a horizontal layer, feathery, wispy, transparent. Okay. So, that is the case of your high level cloud. Now, it can be either in a in an absolutely distributed manner, in a layer like manner, or in an accumulated manner. So that is where either it can be cirrus, cirrocumulus, or cirrostratus. Mid level, it can either be horizontally developed, it can either be vertically developed. If it is mid level horizontal, altostratus. If it is mid level vertical, altocumulus. Low level, no prefix is required. Stratus, cumulus, these are low level clouds. Then you have stratocumulus. What is stratocumulus? The name itself tells you it has the combination of both of the characteristics. So a cloud which will have a large horizontal base but will also develop slightly vertically. That is your stratocumulus, a combination of both. This is also a low level cloud. Then you have rain bearing. They will always cause rainfall. Nimbostratus, multi layered cloud which is horizontal. Cumulonimbus, multi layered cloud which is vertical. Follow this logic, and this is the coverage of the type of cloud. So, if you take a look at the types of clouds, you have cirrus, cumulus, stratus, the major classification. Okay, cirrus is very feathery, wispy. Cumulus is accumulated like heaps of cotton, and stratus develops horizontally. Okay, like a layer. So that is basically your understanding of the types of clouds. Okay, I hope that is clear. These are the clouds which are known as your cirrus clouds. Very high level cloud, as in 10 kilometer, 12 kilometer height, almost to the top of troposphere. They will rarely cause rainfall, rarely causes rain. Why? Because first of all, water is not present, or condensates are not present in high density. Secondly, even if, let's suppose, an ice particle starts to fall, it has to cover so much distance, it will melt into liquid water droplets, it will still experience so much amount of air resistance, it will evaporate before falling on the ground surface. Okay, so it evaporates before falling on the ground surface. That is why rarely associated with rainfall. Now, it will create these beautiful rainbows because the light passes through it, it is almost transparent. Early in the mornings and late in the evenings, sometimes you see that orange color or yellowish color of the sky and the cloud. That is created by these cirrostratus, and in most of the cases cirrostratus, but cirrus also creates those colorations. Then this is the height distribution. Observe this. So you basically have cirrus, cirrocumulus if they are in small chunks, right? Then you have cirrostratus. Then you have in the mid level altostratus, altocumulus. In the low level, you have the case of cumulus, stratocumulus, stratus. Then you have cumulonimbus. This can be on its own more than 12 kilometers, 10 to 12 kilometers. Then you have nimbostratus as well, which again will also cause rains. Okay, so that is the case of these particular clouds. Okay, I hope that is clear. This is the example of your nimbostratus. In the case of nimbostratus, as you can see, it forms a layer. Most of you right now, especially in the northern part of the country, you would be observing, and even in the Western Ghat region, you would be observing some of the nimbostratus clouds. Okay, so this is where it covers the sky. It won't rain heavily, but it will create slight drizzle, moderate rain for a very long period of time. So many of the times you would receive rainfall which starts, let's suppose, at 4 p.m. in the afternoon, continues till 10 p.m. at night. But the rainfall is not very heavy, it is disturbing. So that is the rainfall caused by nimbostratus. Moderate rains, but continuous. But continuous rains. Okay. Then nimbus is rain bearing. That is why nimbostratus brings rain, cumulonimbus brings a lot of rainfall. This is the most violent of the clouds which are created. That is cumulonimbus. Cumulonimbus, always associated with thunder and lightning. In the evenings, always associated with lot of lightning strikes, heavy amount of rainfall. Sometimes you would have experienced that it rains quite heavily, so heavily that even if you step out for 2 minutes, you will get completely drenched. But it gives you certain gaps in between. After, let's suppose, 15 minutes or half an hour, you will get a 5 minute window. That is the case of cumulonimbus clouds. Okay, during cyclonic formation, etc. In the case of the cold front, in all these cases, you have cumulonimbus always created whenever you have vertical rise of air. Okay, that is when this kind of cloud formation is always observed. It is associated with thunder and lightning. But let us understand, why does thunder and lightning occur in the first place? Why do we have the case of a thunder and lightning in the sky? So, first things, when we talk about lightning, one thing that you have to understand is, let's suppose this is the ground surface. This is the case of a cloud, another cloud, let's suppose. 80% of the lightning will occur between the clouds themselves. Okay? Of lightning occurs amongst the clouds. Only 20% occurs between the cloud and the ground surface. Otherwise, 80% is between the case of the clouds amongst themselves. Okay. So that is the case of the occurrence of lightning. But why do we experience lightning? Lightning occurs because of the sudden flow of charge. Huge amount of charge flows in the shortest possible time. That is why you experience lightning. And lightning is a kind of a disaster in a country like India. Every year, in states such as Andhra Pradesh, Bihar, Uttar Pradesh, West Bengal, Assam, in these kind of states, you will always observe that around 200 to 400 lives are lost annually because of lightning storms. Okay, so why do they occur? They occur because of the basic principle that you would have studied in your class 6. What is that? In class 6, you would have in your book some of the basic experiment that you rub your fingers together, there is charge which develops on your fingers. Or you take a wooden scale or a plastic scale, you rub it against the woolen cloth, then you put it over pieces of paper, the paper will be attracted to the plastic scale. You would have observed this, isn't it? Why does it happen? Because when the particles collide with each other, there is a gain and loss of electrons, there will be development of charge. Simple as that. Now, let us understand that in a slightly greater detail. Let's suppose there is a particle here, equal number of protons and uh, electrons, neutral charge. There is another particle which is falling. As it is falling, it will collide with this one and then it will fall further. In this process, can we imagine a situation that it would have gained an electron? It would have robbed an electron. Let's name this particle 1. Let's name this particle 2. So 2 has gained an electron. So what is the charge of 2 in this case? 2 will be negatively charged. Now 1 has lost an electron. Ideally, in an atom, number of electrons equal to number of protons. That is why it is neutral. But let's suppose here one electron has been lost. Then what will be the charge of one? One will have a positive charge, isn't it? Now, if I take this example in the case of clouds, you have multiple particles at different levels, multiple particles. Now, which particles will start to fall? Which are heaviest? Which are the particles which are the heaviest? Where lot of condensation has happened over a period of time, so probably they are at the top. Lot of condensation has occurred as the air has risen up. So from here, larger particles, they start to fall down. As they start to fall down, they will rub against multiple different particles, isn't it? They will be rubbing against multiple of these different particles. As they rub against and hit the multiple particles, they will gain what? An additional electron, a negative charge. So that is where you will have combination of negative charges as these particles accumulate at the bottom. Whereas, like one, like one, the other particles will have a positive accumulation of a positive charge, isn't it? Now, in this case, what happens? You will have the flow of charge, and a lightning is observed in the sky. But if the cloud is very large, like a cumulonimbus, it will have a lot of these negative and positively charged particles out there, isn't it? Now, what is the charge level of ground? Ground is always considered to be neutral, zero charge, always, in most of the cases, considered to be zero charge. That is the reason why you have earthing in the case of your electrical appliances also. So, that is not always continuous inside the cloud, but very frequent inside the clouds, provided the clouds are thick enough. Now, imagine if you have a large field, farm area, right? In that farm area, generally trees are very less. Now, imagine there is one large banyan tree of sorts in that entirety of farm area. Now, when you consider the banyan tree, it is linked to the ground, attached to the ground. It is a projection of what? A zero charge. Current always flows or charge always flows from a higher potential to a lower potential. So, this is when the charge will flow immediately from negative to the zero, and lightning strikes the ground. That is why very tall buildings, large trees in the middle of farmlands, these are very prone to the case of lightning strikes. And what do people do? People basically, when they experience heavy rainfall, they immediately take shelter underneath a tree, especially farm laborers, etc. They take shelter underneath the tree, and they don't know that the tree is the most prominent area where you can be hit by the lightning strikes. And that is where all this charge eventually flows to the ground. High voltage current passes through. So much heat is produced that your body basically burns. And that is where immediate death is caused. This is the reason for lightning. But why do we experience thunder in the first place? What is the reason behind the thunder? From your childhood days, your faculties or your teachers would have made you rectify that light travels faster than sound. That is why you see the lightning, you hear the thunder later. But why do you hear the thunder? What is the reason behind it? The reason is associated with the air. Now, if you consider the air parcel in this region, where the lightning has struck, collision of clouds, but clouds are not solids. So, how will collision of clouds produce thunder? Right. Again, that is where our cartoon movies have taught us so much, that two clouds came, they collided, they started moving away, and you have Tom and Jerry moving between them. But on a serious note, if you consider the air immediately around lightning, now this is where you have had thousands of kilovolts passing through in the minutest possible time, microseconds. So the air has got immensely heated. The temperature of the air in this air column, sudden and extreme rise of temperature is experienced. Sudden and extreme rise of temperature is experienced. Now, what happens when you heat the air? Whenever you heat the air expands, right? Here, in this case, air is heated suddenly. So you have sudden and violent expansion of air and violent expansion of air. And this sudden and violent expansion of air will produce a sound. And that sound is your thunder. Okay? That is why you have the case of thunder. Thunder is not because of, this was, by the way, a PYQ. We will discuss that tomorrow, possibly. That this is the case of where you have the in a PYQ, the question was asked that why is thunder produced. One of the options there was collision of the clouds, right? Many of the candidates did mark that, but it is not because of that. It is because of the sudden and the violent expansion of air that thunder is heard about. If that would have been the case, that only due to collision of clouds thunder is produced, then this cloud would not have produced, or this event would not have produced a thunder. Right. What is the effect of the positively charged particles? They will continue to sustain the lightning events. If once the charge moves through, there will be zero or neutrality which will be gained. Again, if positivity is gained, so you will have pockets of this positive negative charge. Okay, no impact on the ground. Okay. Now, what causes thunder and lightning? So basically, you have the case of electrical discharge caused by the buildup of static electricity in the clouds. Thunder is the sound produced by the rapid heating and expansion of air during the lightning strikes. Okay, this is clear. Then we come to the topic, that is the types of rainfall. When you receive rainfall, why do you experience rainfall? You have the cloud formation, you have the case of rainfall. But why do the cloud formations take place is the reason of the classification of the types of rainfall. So, when you talk about the types of rainfall, broadly classified into three kinds: convectional, orographic, and frontal or cyclonic. Convectional, due to the process of convection. What is the process of convection? Warm air rises up, cools down, creates condensation, cloud formation, which will bring rains. Convectional rainfall. Now, why has that happened? Because during the daytime, the solar energy has heated the ground to such an extent that water vapor has evaporated, created the cloud, and led to convectional process. That is convectional rainfall. Then, orographic or relief. Moist air is coming. There is a physical barrier like a mountain or a plateau. It hits it, forced to rise up, loses temperature, cloud formation. Then cyclonic or frontal, the warm or the cold front. Remember, in warm and cold front, we discussed about the case of rainfall that is associated with frontal rainfall. Let us take a look at each one of them in a slightly greater detail. Now, in the case of a convectional rainfall, what happens? Convectional rainfall does occur when there is heating during the daytime, and that heating increases the temperature. The temperature means there is evaporation. Evaporation means rise of air. By evening or late afternoon, you will have the case of cumulonimbus cloud formation, vertical development. Vapor is coming, condensing. More vapor is coming, more condensation. Like that, vertical development will occur. This creates basically, so you see, during the day, there is heating. Then you have the case of dense cloud formation, and these cloud formations will bring rainfall in that area itself. Okay, so where will you experience this? The regions where you will experience this. You will experience this in the regions around equator, right? You will have the case of daily afternoon rains. Daily afternoon rains along with thunder and lightning. Okay, around 4 p.m. These are also sometimes referred to as 4 p.m. rains. Does not mean it will happen only at 4 p.m. It does happen at 5 p.m. also, 6 p.m. also. But heavy rains associated with cumulonimbus clouds. Cumulonimbus clouds. Okay. Now, at the region of equator, you will observe that. Then islands in the tropical regions like Andaman, Nicobar, Lakshadweep, Maldives, in those areas also. Islands along tropical regions. Okay. In all these areas, you will have convectional rainfall. Then you have the case of orographic. Remember, in geomorphology, we had discussed that anything associated with orogeny, orography, is something to do with a mountain system. Orographic basically is wherever you have moist winds experiencing a physical barrier, a hill, a mountain, an escarpment. In all of this, there's a physical barrier. Now, what happens in that case? As you have the moist air which comes in, moist air which was coming in is now forced to rise up because there is a physical barrier in the form of a mountain. In a simple diagram, something that you can also reproduce on your answer papers. So, imagine if you have a mountain system like this. Okay. Now, this is the region here, let's suppose. Now, if you have moist winds coming from the ground surface from this direction, now the moist winds don't have any direction to go to or any place to go to. The moist winds will be forced to rise up, right? So, here also you see that the moist winds are forced to rise up. As they are forced to rise up, there will be cooling, expansion, cooling. And that is when they will create condensation. This will always lead to huge amount of rainfall on one side. By the time that the air comes here, the air is already dry. All the water vapor has been drained out of it. And then the air starts to sink. This is where there is adiabatic compression. It is moving into the region of high air density. So that is where it will compress, it will warm. Warming means what? Carrying capacity of the air will increase, which means what? Relative humidity will reduce. which means it will become more unsaturated. Rainfall condensation will not occur. So these regions are generally the area of dry descending air. The side facing the wind, that is what is referred to as the windward side of the mountain. The side against the wind is known as your leeward side. This is the side which doesn't receive rainfall. That is why it is also known as the rain shadow zone. That is the reason why now I take you to the map of India. In India, majority of the regions when they experience rainfall because of orographic conditions. Rainfall distribution in India we will cover separately in Indian geography, Indian climate. But here I want you to take a look at the map of India. And if you observe, see, moist winds come from the region of the Arabian Sea. First, they are confronted with the escarpment that is your Western Ghats. The winds are forced to rise up. That is why such heavy amount of rainfall. Western part of Western Ghats receives very, very heavy amount of rainfall. Then the air sinks, comes to the leeward side. That is why these areas are comparatively drier. But why is it that Bangalore is cool comparatively? Because in this area, there is a gap. Through those gaps, winds come in to the region around Bangalore Plateau, and there you receive rainfall. In the meanwhile, winds from the region of Bay of Bengal, as they enter, immediately carrying so much amount of moisture, they face the hills of Garo, Khasi, and Jayantia. Such heavy amount of rainfall, that is why Cherrapunji and Mawsynram receive the highest rainfall across the world. Okay? So think about it. Just to give you a stat, when we talk about Mawsynram, it receives a rainfall of almost 1143 centimeter per year. Shillong, which is quite close by, as in more than 100 kilometer definitely, Shillong receives almost around 140 centimeter per year. So you see the difference. Difference is huge. Why? Because this is on the windward side, and this is on the leeward side. Okay? That is the reason why Shillong will receive comparatively lesser amount of rainfall. It has all got to do with the orographic conditions. Now, you always hear about the fact that northeastern part of the country receives very heavy amount of rainfall. Right now, you have the case of the Assam floods as well, devastating floods. Why is it so? Once the air hits the region of the Himalayan mountains here, moist winds are divided. One goes to the west, right? Other comes to the east. The one which comes to the east, observe the shape of the mountains in the east. Garo, Khasi, Jayantia, Mikir, Barel, Dafla, Miri, Mishmi, Abor, Naga, Patkai Bum, all of these mountain ranges, they form like a funnel. Moist air can go in, they will have to hit some of the hill and they will have to cause rainfall. That is why even the slightest amount of moisture brought into that region always is associated with heavy amount of rainfall. And on top of that, observe, rainfall will be caused where? In the hills, in all these hilly areas, lot of orographic rainfall. Water from the hills comes to this bowl shaped land, that is Assam. And that is where flooding naturally occurs, isn't it? The reason why Ladakh is a cold desert, you have here the Shivaliks, the Himachal, the Trans Himalayas. So moist air rises up, causes rainfall on this part, is almost dry. But the middle Himalayas again push it up. Slight amount of rainfall will be caused here as well. By the time that they reach the region of Ladakh, they have already crossed three to four of the highest mountain ranges of the world. They have no moisture left. That is why Ladakh is a cold desert. So, majority of the parts of India receives rainfall because of orographic conditions. Then you have the frontal rainfall. When you have a warm and a cold front, in any of the case, when you have the air in contact. So, can we say on leeward side only forest fires occur? Not always necessary, but in majority of the cases, definitely so. Yes. It also is seasonal, by the way, on which season you are talking about. Okay. For example, the forest fires that you observe in Uttarakhand, in the region of Himachal Pradesh during the month of May and June, is not necessarily always in the leeward side only. Sometimes it can be in the windward side also. Okay, so that is where it is the winds which further spread it over a larger distance. Now, in the case of a frontal rainfall, what happens? Observed in mid latitudes, obviously. If you have the warm air rising up, right, it gets in contact with the cold air layer, and that is where it will lead to cloud formation and cause a lot of rainfall. So, this is the kind of rainfall which is experienced. Okay. Now, this portion deals with the case of where the rainfall occurs. Okay, by the way, cyclonic or frontal rainfall, you even when you have the formation of a cyclone, there also rainfall can occur. For example, tropical cyclone will create a lot of rainfall. So cyclonic disturbances can also create that is not frontal. Tropical cyclone is not frontal. Temperate cyclone is quite frontal. Okay. So I hope tropical cyclone is very clear to everyone now. If you are interested in that, go after this session, look into the satellite image of this area of Pacific. You have a super cyclone which is developing, which is going to hit this region. Do observe that. Do observe the eye, which has around 7 mile of depth or thickness, which has developed. This is your super cyclone dolphin, which has developed in the region of Pacific. Observe it in the satellite image. There is another cyclone developing here as well. Okay, so that is what you can basically look at it in the map, and you can get a deeper understanding as well. Now, this region, when we talk about, so where in the world do we have rainfall? Yes, Pratima, correct. So rainfall will be caused wherever you have rising air. For example, in India, which kinds of rainfall will be received? You will have the case of orographic rainfall, and you will also have the case of cyclonic rainfall during the monsoon season. But in various different parts of the world, where will you receive rainfall? Wherever you have rising air column, isn't it? As per the tricellular model of circulation, we have observed you have rising air column in the region of the equator, that is the ITCZ, dense cumulonimbus cloud formation, and also around 60 degrees. This is not created because of heating. This is created because of the dynamic movement of air. And that is where here also you will have the frontal cloud and the frontal rain formation. India convectional rain occurs in the region of lower latitudes, closer to the coastline in certain areas, and in islands, their convectional rain does occur. Yes. Okay. So, in these areas, you will observe the case of the frontal rainfall. In these, you will observe convectional rainfall. Okay? But across the world, wherever you have wind systems which are onshore means coming from the sea to the land. They will carry the moisture from the sea and they will dump it over the land areas. That is the reason why in the region of Westerlies, the areas of Great Britain, etc., they have huge amount of rainfall. Rainfall occurs almost on a daily basis. You have maritime air in these areas. So, in the lower latitude, let's summarize this. Lower latitude, that is equatorial regions, equatorial regions, which kind of rainfall will be observed? Convectional. Okay. In the mid latitude, you will observe frontal. In other places, onshore winds. Onshore winds will create orographic, orographic rains. So that is how you have rainfall, for example, even when you consider the region of Gulf of Mexico. Here you have trade winds. Florida receives a lot of rainfall. Okay. If you consider the region around South China Sea, receives rainfall. Thailand, Vietnam, in the rainy season will receive rainfall because of the onshore winds. Okay. So that is the condition of rainfall. Once you know this basic along with the tricellular model, now take a look at this lecture. This is the QR code. You will find the link for this lecture. Okay. Go to this lecture. It is the entirety of climate classification of world climate. Take a look into this. This is more than sufficient for your coverage for the exam. Okay. Tomorrow in the session, we will be discussing the PYQs associated as well. I hope the concepts are clear associated with the types of rainfall, the global distribution, and also the case of thunder, lightning, and so on. Right? If you have deepened the concept, let us know in the comment section. Click on the like button. See you tomorrow. Till then, do take care of yourself. Goodbye. Thank you.